Okay, this is question 8.2 of the calculus question. And what they want us to do is to find the turning point. So the function, they tell us the function actually is minus x cubed. It's a cubic function, plus x squared plus x plus 2. And they want us to find the turning points. Well, gee, we've got the x values of the turning points already because this is the equation of the gradients and of the derivatives of the gradients f prime. So we've got the value of x that makes the gradient 0. That is a turning point. So we know that the x value of 1, if we just put it in there, if we could find f of 1, in fact, we do. If we take f of 1 and we put it into this function, we get 3 out. So that's one of the turning points, 1 and 3. If you take minus a third and you put it into the function, you get about 1.81 or 49 over 27. So there's your two turning points. That's all there is to it. Now they want you to sketch the graph. Now, if x is 0, well, y is 2. It's pretty easy to see the y-intercept right there. If x is 0, y is 2. It's also pretty easy to see the x-intercept of this function because if you could find something you could put in here that would make it a y0, then it's an x-intercept, whatever makes y0. And you could try just some basic, you know that 1's not going to work, but if you go 2, hey, it makes it 0. In fact, f of 2, and I just put 2 in there, just sort of trying it. There was 1, I tried the next one, 2, and it made it equal to 0. Now you know this is a cubic function, so you should have this idea of how a cubic function works. It's got to go like that. It curves and then it goes down at the end. That's the basic shape of a cubic function with a negative in front. So I know it's like that. I know it goes through 2. I know it turns on minus a third and 49 over 27. So it's got to turn here, hit the 2, and then turn at 1 and 3, and then come back down and hit this 2 here. Now you should put nice little arrows on it and all that stuff to make the functions a little bit nicer, you know, like that if you were doing it and graphing it. I cheated and got a computer to do it, but there, if you just draw this graph, you get one for the shape. If you put in the intercepts of 2, and 2, the y-intercept and the x-intercept of 2, and you label the turning points, it doesn't have to be perfect. It just has to be reasonable, and you'll get all the 5 marks. Okay, that's question 8.2.